So welcome once again for this new lecture. So today our topic is going to be registers. In the last lecture we have discussed about bus and its architecture. So in this lecture our focus is to be on what are the different registers that we use in the CPU. So this is a quick recap to the memory hierarchy. So as we know we have different types of memory starting from CPU registers, then cache memory, then main memory and secondary memory. So as we go towards this secondary memory from the CPU register, so the overall capacity of the memory increases, and as we go up from secondary memory to CPU register, so the speed of the memory increases and along with its cost. Now the CPU registers are actually made up of flip-flop, right? So what exactly is a register? So register is a digital device which is a that is the fastest memory unit which can accept, store and transfer data or instructions. So what exactly is a register? It is a group of flip-flop where if we say we have a n-bit register, so it would be having n flip-flops, right? And basically these registers are actually static memory. Okay. Now what is a flip-flop? So flip-flop is actually an electronic circuit which is able to store a bit. And as we know, a bit can be a 0 or a 1, right? So there are two broad categories of register. So one is special purpose register and other one is general purpose register in the CPU. So special purpose register, as the name itself is self-explanatory. So these registers are reserved for some specific purposes. Like if we take some example, so we have program counter. So program counter basically stores the address of the next instruction which is going to be executed. Similarly, we have memory address register, memory data register, instruction register, flag register. So we'll discuss uh, the specific functionality of these registers, right? Similarly, we have general purpose registers. So these general purpose registers are basically used in the system to store uh, some sort of intermediate results, right? And these registers are actually accessible by the user. Okay, like by writing some sort of instructions, by writing some sort of assembly language instruction, we can access these registers, right? So the example is accumulator and data register. Okay, so this is a top level view. So here we can see the different registers. So starting from the program counter, then we have memory address register. Okay, then instruction register, memory buffer register, input output address register, input output buffer register, right? And this CPU is connected through a system bus with the IO module and the main memory, right? So now we'll be discussing what are the specific use of these registers. So starting from program counter. So program counter. So you can remember this with the name count. So count is something like we have. If we start the counting from 1, so next is going to be 2, right? Then after 2 we'll be having 3. So similarly this program counter is actually keeps the count of the program, keeps the count of the instruction. So it contains the address of the next instruction that is going to be fetched from the memory, or you can say which is going to be executed. Similarly, we have memory buffer register, right? So memory buffer register, it actually stores a word to be stored in the memory or to be read from the memory, right? This is a kind of communication when CPU communicates with the memory unit. and it wants to send some data or receive some data from the memory. So that data comes through memory buffer register. Similarly, we have memory address register, right? So memory address register is something like whenever we want to read some data, we have to specify the address, right? Suppose CPU is there, CPU wants to read some data from the memory unit. So it will first specify the address from where the data is going to be read. So that address would be stored in the memory address register. And once the data would be read, the data would come through memory buffer register. Okay. Uh, and if we, I hope everyone is aware of the concept of buffer. So buffer, basically it is a term that is used to compensate between the uh, speed difference of two communicating units, right? So as we know, we have either we have memory unit or input output unit. So they are comparatively uh, slower as compared to the speed of the CPU, right? So to compensate between the speed of the CPU and the IO devices or memory unit, we use the buffer register. So we have memory buffer register to compensate the speed of the main memory, and similarly we have input output buffer register to compensate for the speed of the input output units, right? Memory data register, as the name suggests, it is going to read the data from the memory. Whatever the data, whatever the word that would be read from the memory or that is to be stored in the memory, it will just go through memory data register, right? Then instruction register, as the name suggests, it will contain the instruction that is fetched from the memory. So obviously we know program is a set of instructions. So whenever we execute any program, so it would be executed instruction by instruction, right? So whatever the instruction we are fetching from the memory for the execution purpose, it will come through IR, that is instruction register. Then we have a flag register. So flag register basically to indicate the different operations, right? So flag is something which will have either a 1 or a 0. So it have a two states. So one is set. So set means 1 or reset means 0. Okay. So whenever any arithmetic or logical operation is being performed by the ALU, so flag register would indicate the value of the result, right? Uh, on the basis of whatever the flag value is, whether it is 0 or 1. Then we have accumulator. So accumulator is something when we talk about single address instructions. So uh, one of the data value we would be getting from the through the accumulator, right? So it is something that is to accumulate the intermediate result to hold the temporary results or temporary operands. So if I take one example, let's say we want to add two values. So if we have already read one value from the memory, so it is going to be stored in the accumulator, and the operation is going to be performed once we have the second value from the memory. So it is to hold the operands on which you are going to perform the operations temporarily, as well as whatever the results, temporary result we are having from the ALU, that would be stored in the accumulator. Then data registers, again these registers are used to store the data temporarily whenever we are communicating with any peripheral device, any input output device, right? Then in the indexed, uh, whenever we talk about indexed addressing mode, so there comes index register in picture, right? So index register is something which is used for indexed addressing. Okay. So whenever we want to have some, actual address that is to be accessed with the help of some sort of index addressing mode we are using, and some sort of index we want to use to have the actual address. So in that case, this index register would be required. So these were the different registers that we use. that we have in the CPU, right? Now there is one multiple choice question. So a register is defined as a group of latches for storing one bit of information, the group of latches for storing n bit of information, a group of flip-flop for one bit of information, a group of flip-flop for storing n bits of information or multiple bits of information, right? So, which is going to be the right answer? Obviously, register is something that is a collection of flip-flop to store n bits of register. So the right answer is to be is D, right? Option D is the right answer. So I think this is all about this lecture. In the next lecture, we'll discuss about bus arbitration techniques. Thank you.